Romex, also known as NMB, is a type of insulated electrical cable. It combines two or more insulated conductors or wires within a flexible plastic sheath. It is typically used for residential wiring, and its flexibility allows for easy installation. Service conductors are individual, uninsulated wires used for heavy-duty electrical applications, such as service entrances or subpanel connections. They are typically much larger in gauge than Romex wires and require additional protection. For a 125 amp subpanel, conductors need to be rated for at least 125 amps. According to National Electrical Code Table 310.15b16, American wire gauge 1/0 Romex or American wire gauge 2 service conductors are both acceptable for this application. Service conductors do not have a specific color code. You can use 3 black wires for all 3 phases, 2 positive and 1 neutral. You only need 3 wires, 2 positive and 1 neutral, for a 125 amp subpanel. Yes, you need to run a separate American wire gauge 8 protected wire for the ground connection of the subpanel. Yes, you can run all 3 wires together in the same polyvinyl chloride conduit. In fact, the National Electrical Code requires that all conductors, phase, neutral, and ground, be run in the same conduit or raceway. American wire gauge 1/0 Romex is not commonly available at hardware stores, so you will likely need to use service conductors for this application. It's important to follow all local electrical codes and obtain a permit before doing any electrical work. It's also wise to consider hiring a qualified electrician to ensure the installation is safe and up to code. Let's delve into some more details regarding electrical wiring for a 125 amp subpanel. Firstly, understanding the ampacity of conductors is paramount. Ampacity refers to the current, measured in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The National Electrical Code, or NEC, provides tables, specifically Table 310.15b16, that dictate the allowable ampacities for various wire gauges and insulation types. This table takes into account factors like the conductor material, copper or aluminum, the insulation temperature rating, and the ambient temperature. It is crucial to consult this table to ensure that the chosen conductors are adequately sized for the intended load. Secondly, when selecting between Romex and service conductors, consider the application and environmental factors. Romex or NMB cable is suitable for dry indoor locations. It is commonly used for residential branch circuits for lighting, receptacles, and small appliances. Service entrance cable, or SE cable, and individual conductors like THHN or XHHW are often used for feeders and service entrances where greater ampacity or environmental protection is required. Service conductors are typically installed in conduit, providing mechanical protection and allowing for wet or outdoor locations. In the context of a garage subpanel where moisture or physical damage may be a concern, service conductors and conduit may be a more robust choice than Romex. Thirdly, grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices such as circuit breakers to trip and energize the circuit. The grounding electrode conductor connects the grounding system to a grounding electrode, such as a ground rod or metal water pipe. Bonding ensures that all metallic parts of the electrical system, such as conduit, enclosures, and equipment, are electrically connected to create an equipotential plane. This minimizes the risk of electric shock by preventing voltage differences between metallic parts. A separate equipment grounding conductor, or EG, must be run with the circuit conductors to the subpanel to provide a dedicated grounding path. The size of the EGC is determined by National Electrical Code Table 250.122, based on the size of the overcurrent protection device. Fourthly, conduit fill is an important consideration when installing conductors and conduit. The National Electrical Code specifies the maximum percentage of conduit cross-sectional area that can be occupied by conductors. This is to ensure adequate heat dissipation and to prevent damage to the conductors during installation. The allowable fill percentage varies depending on the number of conductors in the conduit. For 3 or more conductors, the maximum fill is typically 40%. To determine the appropriate conduit size, consult National Electrical Code Chapter 9, Table 1, and the conduit manufacturer's specifications. Fifthly, overcurrent protection is essential for protecting conductors and equipment from overload and short-circuit conditions. Circuit breakers and fuses are the most common types of overcurrent protection devices. Circuit breakers are resettable devices that trip when the current exceeds the breaker's rating. Fuses are one-time use devices that melt and interrupt the circuit when the current exceeds the fuse's rating. The overcurrent protection device must be sized to protect the conductors in the circuit. The National Electrical Code specifies the maximum allowable overcurrent protection for various conductor sizes in Table 310.15b16. It's important to choose a circuit breaker or fuse with an interrupting rating sufficient to handle the available fault current at the point of installation. Sixthly, torque specifications are critical for making reliable and safe electrical connections. Over-tightening or under-tightening connections can lead to loose connections, overheating, and even fires. Electrical equipment manufacturers provide torque specifications for all connections. It's important to use a calibrated torque wrench to ensure that connections are tightened to the proper torque. The National Electrical Code Section 110.14d requires that all connections be torqued to the manufacturer's specifications. Seventhly, arc fault circuit interrupters, or size, provide enhanced protection against electrical fires. A size detects arc faults, which are dangerous electrical conditions that can occur when insulation breaks down or connections become loose. Arc faults can generate heat and ignite surrounding materials, leading to a fire. A size are designed to trip and de-energize the circuit when an arc fault is detected. The National Electrical Code requires a size in many locations in dwelling units, including bedrooms, living rooms, and dining rooms. While not typically required for garage subpanels, installing a size can provide an additional layer of safety. Eighthly, surge protection can protect sensitive electronic equipment from voltage surges caused by lightning strikes or power grid disturbances. Surge protective devices, or SPDs, are designed to divert surge current away from protected equipment. SPD are available in various types and sizes, including whole house SPD and point-of-use SPD. Whole house SPD are installed at the main electrical panel and provide protection for the entire electrical system. Point-of-use SPD are installed at individual outlets or equipment and provide localized protection. Given the increasing reliance on electronic devices in homes and garages, surge protection is a worthwhile investment. Ninthly, electrical permits and inspections are essential for ensuring compliance with local electrical codes and for verifying the safety of electrical installations. Most jurisdictions require electrical permits for new installations, alterations, or repairs to electrical systems. Electrical inspections are conducted by qualified electrical inspectors to verify that the work has been performed in accordance with the National Electrical Code and local amendments. Obtaining the necessary permits and inspections is crucial for avoiding potential fines, delays, and safety hazards. Tenthly, working with electricity can be dangerous, and it's important to take precautions to protect yourself from electric shock and arc flash hazards. Always de-energize circuits before working on them by turning off the circuit breaker or removing the fuse. Use insulated tools and wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Additionally, consider the following points for ensuring a safe and code-compliant 125 amp subpole installation. 1. Conductor sizing and ampacity. Ensure that the conductors selected for the 125 amp subpole are properly sized to handle the intended load. Consult National Electrical Code Table 310.15b16 to determine the allowable ampacity for various conductor sizes and insulation types. Consider factors such as ambient temperature and rating for multiple conductors in a raceway. 2. Overcurrent protection. Install a 125 amp circuit breaker in the main panel to protect the feeder conductors supplying the subpanel. The circuit breaker should be properly sized to protect the conductors in accordance with National Electrical Code Section 240.4. Ensure that the circuit breaker has an interrupting rating sufficient to handle the available fault current at the point of installation. 3. Grounding and bonding. Establish a proper grounding and bonding system for the subpanel. Install a grounding electrode conductor from the subpanel to a suitable grounding electrode, such as a ground rod or metal water pipe. Bond all metallic parts of the subpanel, including the enclosure, conduit, and equipment, to create an equipotential plane. Run a separate equipment grounding conductor from the main panel to the subpanel to provide a dedicated grounding path. 4. Wiring methods. Choose an appropriate wiring method for the installation, such as conduit or cable. If using conduit, ensure that it is properly sized and installed in accordance with National Electrical Code Chapter 3. If using cable, select a cable type that is suitable for the environment, such as NNB cable for dry indoor locations or UF cable for wet or outdoor locations. 5. Conduit fill. When installing conductors in conduit, ensure that the conduit fill does not exceed the maximum allowable percentage specified in National Electrical Code Chapter 9, Table 1. Use the appropriate conduit size for the number and size of conductors being installed. Consider directing the ampacity of conductors if the conduit fill exceeds 40%. 6. Wire connections. Make all wire connections in accordance with National Electrical Code Section 110.14. Use appropriately sized connectors and terminals for the conductors being used. Torque all connections to the manufacturer's specifications using a calibrated torque wrench. Ensure that all connections are clean, tight, and free from corrosion. 7. Labeling and identification. Label all circuits and equipment clearly and accurately. Use permanent markers or labels that are resistant to fading and peeling. Identify the purpose of each circuit breaker in the subpanel and the areas or equipment that it serves. Label the subpanel with its voltage, amperage, and other relevant information. 8. Working space. Provide adequate working space around the subpanel to allow for safe and convenient access. National Electrical Code Section 110.26 specifies the minimum working space requirements for electrical equipment operating at 600 volts or less. Ensure that the working space is clear of obstructions and that there is sufficient lighting to perform work safely. 9. Panel board selection. Choose a panel board that is appropriately sized for the intended load. The panel board should have sufficient capacity to accommodate all of the circuits that will be installed. Select a panel board that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or electrical testing laboratories. 10. Arc fault circuit interrupter and ground fault circuit interrupter protection. Consider installing arc fault circuit interrupters to provide enhanced protection against electrical fires. Arc fault circuit interrupters detect arc faults, which are dangerous electrical conditions that can occur when insulation breaks down or connections become loose. Install ground fault circuit interrupters to protect circuits serving wet or damp locations, such as bathrooms, kitchens, and outdoor areas.